Alright. Yesterday we started with graphing y equals sine theta. And again, we use the unit circle to help us around at 0 degrees because this axis represents our angles. At 0 degrees, it's 0. At 90 degrees, so that's pi over 2. It's at 1. At pi is back to 0. 3 pi over 2, negative 1. And then back here at 2 pi. So it looks like this. Now there's your basic y equals sine theta graph. What's the period of that graph? What is it?
2 pi.
2 pi. It repeats after 2 pi radians, it'll repeat itself and do the exact same thing. What is the domain of this graph? Yep, goes forever. Again, you gotta go left, you gotta go right. So you start to the left, negative infinity, positive infinity, x is an element of all reals. What's the range for this graph? Right? Negative 1 to 1. Your low point, negative 1, your high point, plus 1. So that's your range. Okay? What's the amplitude of this graph? 1. Okay, maximum displacement from here to here. Okay? So, what does that do to my graph?
The amplitude is increased.
The amplitude increases to 3. So my maximum becomes 3, my minimum becomes negative 3. So that's all that changes. This is referred to, this A value is referred to as the amplitude. Okay? When we have a value in front of the theta, what happens to the graph? Gets what? Narrows. Sure, that works, right? By how much? Half that. So what are we doing to the actual graph to get the new one? Dividing all the x values by 2. That becomes pi over 4, pi over 2, pi over 4, and 1 pi. So now it repeats itself. What's the period of this graph then? When does it repeat itself? Pi. Right? How do we get the period? If we're talking radians, how do I get the period?
2 pi over b.
Take 2 pi and divide it by whatever the b value is, which is found in front there. Pretty straightforward, right? So in this case, I put that 2 down here. 2 over 2 is 1. 1 pi becomes my period. So that was yesterday's work.
And that has to be absolute, right? Absolute.
Yeah, I don't write it in, but you're right. Okay? When you're talking about a period, you're talking about a number that has to be positive. So it is an absolute value. All right? We wouldn't put the period in as a negative. You're right. Okay? My amplitude, same idea. My amplitude would also be placed in there as a how far are you, which is a distance. So you don't want a negative distance for it. Okay? But if I did have a negative, and I didn't talk about this yesterday, except Emily made mention of it, if I did have that negative in there, what happens to my graph? What happens to this graph when you put that negative in front of the 3? It flips. Over which axis?
The x-axis.
Over the x-axis, so it would look like this, right? Good. So we didn't actually mention that yesterday. That's what happens. All right? Anybody want to ask questions about yesterday's work? Like, not an actual question yet, Carlton, I'll get to that. But what about just what we did here? Anything here? Okay. I'll come back, Carlton, and answer questions. Okay, today. So, let me have a look here. I want to see something first. when we've worked up to this point, for instance, when we dealt with this here, now I got my head. Okay. When I took this graph, I changed it into general form, and I ended up with this: y equals a square root b x minus c add d, right? Okay, so this is the standard equation for a square root, a radical graph, right? Now, what did c and d do to your graph? What did c do to your graph? Where was it? Moved it left and right. Okay? Think about it like this. I have y equals x squared, a different graph. Y equals x minus 2 squared. Which way does it move? Right 2. Correct? Because that's what the c value is for that graph. Same thing with the square root graph. Same thing now with the sine and cos graph. The only difference that you're going to have with the sine and cos graph is the c value is likely going to be an angle, either in degrees or radians. You're not going to usually move it a numerical value left or right. You will up or down. Your d value will shift, okay? But because your axis is in degrees, that's what's going to change your graph. So let's have a look and see. Okay, let's take this graph for instance. Y is equal to the sine of theta minus pi over 2. All right, so let's draw the original graph, which is sine theta. Again, the original graph, just watch what I do here. The original graph is just simply 5 points. 1, 2, 3, 4, and 5. How is it different for cos?
Opposite.
What's the difference with the cos graph? It starts where? At 1. It starts at its maximum value at 0. And then it works its way down and back up. Okay, and that's what the difference is between sine and cos. Okay, so this value right here is pi over 2, pi, 2 pi over here, and this is 3 pi over 2 right here, right? Okay, so what is this telling me to do to my graph then? Move it right pi over 2. Okay, I'm going to extend this guy down and back up. So that would be negative pi, and this would be negative pi over 2. Okay, I'm just doing that for this particular question. All right, so this was my starting point right here. Which way do I move it? Right to there. This guy moves to here. This guy moves to here. This guy down here moves to there. This guy would move out here. And then this guy would move right here. So this graph, pi over 2, to the right, would look like that. So I move everything, all my 5 key x values, pi over 2 to the right. All right? What's the period of this graph? What's the period of it?
It's just under 2 pi,
Why?
so you didn't move over.
That's right. Okay, my b value is still what? Still 1, right? The value in front of your theta is still 1. So all I did was move it pi over 2 to the right. So my period doesn't change, my domain doesn't change, my range doesn't change. The only thing that changed was where I started the graph at.
So then your y-intercept would change then, yeah?
My y-intercept, does it change?
Yes.
Yeah? Yeah, it does. It's now where? Negative 1, right? Okay? Because this is 1 and this is negative 1 down here. You're right. What else changed? Y-intercept changed. What else changed? The x-intercepts changed. Now what are they? Pi over 2. 3 pi over 2.
Yeah.
5 pi over 2. 7 pi over 2, right? So here's, this is important to us. X-intercepts are now where for this graph? How did I write that yesterday? There were two methods I gave you yesterday. What's the first one that you see on? Yeah, you're very close. Gabby, you got the last part of it right. What's the starting x-intercept on that right now? Pi over 2. So yes, Gabby, I can do that.
Okay.
Now I add
Plus.
plus k pi, k is an integer, correct? Right? Okay, so that was the one method. That was the second method I showed you. What was the first method? How did I show every odd value of pi over 2? 2k plus 1 pi over 2 where k is an integer. Right? Everybody okay with this?
Does it matter which way we write it?
No.
Do you have
No.
a way you prefer?
No.
No?
Whatever's easiest for you. Okay? Alright? I equals cos theta plus 2. Okay? What translation takes place now? Go ahead. Where's it go? Up 2. Okay? So, I'll draw in my 5 key points. Those are my 5 key points, right? And I'm going to move them up 2. Right? And so go up to here. Right down. This one's down here, here, here. So, all right. I got another thing I want to talk about. Okay, so does everybody see what happened there? Graph my 5 key points and then just move them up 2 on my grid, right? What is the equation of the line that's the equilibrium position right now? Meaning, where does it cut it right in the middle of your coast graph? What's the equation of that line? It's imaginary, so we don't draw it in, but what is it?
You say that one more time?
What is the equilibrium position now? The equilibrium position was here before, right? That was the halfway point. Now where is it? Y equals 2. So it would be this guy right here, right? That's important to know when we're doing this. Your D value will indicate where this line moves to put it in half. Okay, that is very important to know. So when we begin graphing them, when we have all the translations, that's one of the things that we want to do is move that line up based on what the D value is.
Do we have to draw that in?
No. You will though, because it'll make it easier for you to draw a graph. Okay?
And would you always put your original coast graph first and then move it?
Yes.
That's how you usually do it?
Yeah. Actually, okay, let me do this, Emily. I'm gonna go through this. I don't want you here yet today. We don't need to be here today. So I'm going to just jump ahead here and show you. Just a second. Here it is on here. Okay, so you gotta do something.
What?
I don't know yet. We'll figure it out in a second. Okay, let's look at this. Y is equal to -5,
What page are you on?
162. Sine 1/2 theta minus 90 and add
Yeah, that kind of scares me.
15. Okay, looks terribly complicated, doesn't it?
Yeah.
Okay, so the first thing I want you to do, and this is going to be common practice for us as we go through this. Because when we do the questions, the problems, this is going to be your common practice. So here's what you're going to do. You're going to list this out first. What is A? -5. Which means my amplitude is what? 5. Good. What is B? 1/2. Which means my period then is going to be what? Oh yeah, no, it's double. 720. 720. Good catch. 720, right? 360 degrees, because they put it in there, divided by 1/2. Right? So it's either 2 pi over b or 360 over b. Okay, so far? What about C? What is C? 90? Okay, and what is D? 15. All right, so we got all this in place. Okay, so here's how this works. I have a sine graph. So the first thing I'm going to do is I'm going to draw myself a line and put my 5 key points on the line. This has nothing to do with where the actual axis is. It's just going to be where I start. So first thing I do is do this. I go here, 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 and here. So I'm going to draw it. Because all I'm going to ask you for is one complete period length. So that's what the sine graph looks like. We all agree?
Okay, yeah.
Right? That's it. You put your 5 key points. 0, 1, 0, -1, 0. Right? All right. So now we have to label. We need to start trying to label this. Well, where is this starting point?
That's 15.
This starting point? Not yet.
Okay.
The starting x value is where?
0.
It normally starts at 0, right? But where does this graph start? No? Which way did I move it? Left or right?
Moved it right.
Yeah, we'll just work with degrees.
Okay, moved it right 90.
Yes. So there's my starting point right here. That's at 90. Correct?
Okay, yeah.
Because I moved it, instead of starting at 0, which it's supposed to, this told me to move it right 90. So that's where it's on my equilibrium position. I just move it right 90.
Okay.
Now I'm going to label the last point. How do I know what this point is for x?
360. You add your period.
What's that?
You add your period.
Add my period to it, which is 720. So this becomes 810. Okay, so far? All right. Now, I've got that in place, so that's perfect. I'm just gonna, well, I'm not gonna do it yet. Okay? Extend this. Where is this guy located, this line? Louder.
15.
It's at 15. Because remember, I moved my whole axis up. So let's just go back a page here. So here's my standard graph, right? This red line right here represents my sine graph. Okay? So I moved it 90 to the right, so I moved it to there. And then I moved this, so I'm looking at just this line. So I moved it along this line 90 to the right, and then I moved that line up 15. Right? So I took this x-axis here, which was my equilibrium axis, and I moved it up 15. So that's what I've done. So that's at the 15 right now. Okay, what's the amplitude? 5. So what's this right here? Maximum is at 20, and the minimum is at 10. All right? Over one more. Makes sense now, Brad?
Yeah.
Okay. So then, in other words, my actual x-axis is somewhere down here. And I don't have to be specific with it. I can just place it in there. Okay? And my y-axis is just like that. Over here somewhere. Maybe on a slight angle. Maybe you're just looking at it crooked. Put your head. Sure it's straight. There it is. I just graphed one period of that. That's all you need. Okay, you're never going to be asked for more than that. Ah, what did we miss? We should have flipped it, shouldn't we? So where does that start? Where should have I done that? At any indication of it, at any point when I did this, maybe when I drew the first 5 points, I might have done that. Okay? What did we miss? The negative right here. So I should have done this. Instead of putting them up, I should have had it come down, there, and there it is. There's my entire graph. That's right. So I can do that at the end. I could have done that at the beginning. I can do it in the middle. I just need to know that it's got to flip. So there's your entire graph right there. This is where we're working towards. There's your entire graph right there. So from an equation standpoint, I start by listing out A, B, C, and D, and then I put my amplitude and period in. All right? Now, one sec, Carlton, I'll get you a question. The other thing is, I do the same thing if I have a graph given to me. If the graph is given to me, which is what you're going to have to do, I pull it together by listing A, B, C, and D, and I put in the information from the graph. That'll be the part that confuses you to start today. If I haven't already confused you already. Okay? That'll be the part that confuses you. It's just pulling this off a graph. So what do I do personally? Is first of all, I pick my D value, and I get my period from the two peak positions. So I look at it on the graph and I find it from the two peak positions. But I'm going to come back to that after. Carl, do you have a question about this?
Yeah, with the -5, wouldn't that flip it over the axis?
It flips it over which axis?
Like, yeah, like flip it like right over to like -15.
Over to -15?
Yeah.
Oh.
What do you think?
Multiply my y value by negative. Right?
I don't know.
Does it put all the way in?
Okay, here's the thing. When do we do that flip? In theory, when should we do that flip? At the beginning? Yeah. We should do that flip at the beginning.
And then it doesn't matter.
So then it's down here, Carlton. This is my starting right down here, right? Okay, so if I flipped it, all right, right now I flip it down to here. I'm moving it up 15. So it's still gonna be up here because that is where I'm gonna do it. So that's the beauty of this. You actually can mess that up in the order in which you're supposed to do it and still come out smelling like rose. Okay? So you can do that at the very end in this case. On all the other graphs that we did, we would start with your stretches first and your compressions first, right? And then we would do our shifts, correct? But today, I actually did that. I did this first on the axis, the stretch, but then when it came to labeling, I started with these two guys to label. Do you understand what I'm saying?
Yeah.
So you could have done it, it would have worked your way or it would have worked my way.
I was just looking at it, 'cause if it's at 15, then it has to go right over, but
Right.
we're supposed to already have had that done. So,
Exactly. And then you're moving it all up 50.
Yeah.
Right? Okay, so I'm not timesing this by -5 or whatever. Okay? Is everybody okay so far? That's for this section, that's as hard as it gets. Yeah, Kelsey.
Can you explain once more where the 810 comes from?
Yeah, my period length is 720 degrees.
Okay.
So I've got one complete period happens in 720 degrees. I started the graph by moving it right to the 90. So 90, add 720, takes me to 810. Okay? Are we all right with that?
I know what we're working on.
All right,
What are you working on?
guys, yeah.